So in this part, what we are going to do now, we have learned the theory. We discussed there are three types of basic gates: AND gate, OR gate, and NOT gate. And also we have compound gates. We can combine combinational gates, combine multiple gates together. So we discuss NAND gate and NOR gate, right? Now, then we look at like how this is really connect these gates together. So you can purchase ICs and then you can make simple circuits. Now, when you're given a practical problem, here we are going to discuss how we can handle this, right? Now, the first one we are going to look at the example is a home alarm system. Now, home alarm system in simple cases. Now, if you have an home and then you want to, have security, one idea is, whenever somebody tries to open a door or a window, we can make it an alarm. Now, to understand how this works, so let's assume we will have only one door and one window, right? And if any door or window is open, we want to, make a circuit to switch on the alarm, right? So that's the idea that you are going to say. So if you look at this, these are like some door sensors, automatic sensors. So you see this, so one part of the sensor is put it into the outside of the frame, and the other one actually put it into the door or a window, right? So there will be a, so for a home alarm system, you can have everything. And here you see actually you can program it so that whenever switch is somebody tries to open door or a window, when alarm is set, right, then it'll switch on the alarm. Now, since we have given a door or a window, so we know that the inputs are door and a window, and the output is alarm signal. So now we have to figure out what should be the circuit, right? So first of all, let's take down this, and then we will, right? Now let's assume that we have a door sensor and a window sensor is there. And whenever the door is open or window is open, we want to make the alarm, right? So you need to have an alarm signal. Now let's first of all, you need to put, right? So you need to put these details. So the details are, so how do you represent doors and windows? That part you need to put. Right? The idea is like, let's say we have doors and windows. First of all, we want to define how do you represent when the door is open? So when the door is open, we can say it's 1. Door is closed, we can represent it 0. So that's the idea. So first of all, you can make the states. Likewise, alarm. So there'll be a warning signal. That means that we set it to 1 and no warning, right? When you don't have any warnings, right? So we set it to 0. So now we know what should happen, right? Now what should happen? So there are possibilities when, right, both are closed, door is closed, right? And then window is closed, we know that there's no signal. Right? So in other words, if I put door, window, and alarm, so we know that if both are closed, this should be 0. This is 0. If this is 0 and this is 1, we know this should be 1. Alarm should work, right? Should be warning. 1 0, again warning. 1 1, again warning. So we know that this is basically OR gate. So we know that we can put an OR gate in between to draw the circuit. So we can put OR gate. So this is one input and this is another input, and the output is connected to the alarm sensor. So we know that whenever the door sensor is 1, that means door is open. So alarm is provides you the warning, right? If the window is open, again it will make the alarm, and if both sensors are on, then again alarm provides a warning. So only case where no warning is both door and window are closed, right? So that's a simple one. So this is the simplest circuit possible for you to work. Right. Now let's make it a little bit more complicated. Now the second part of this problem, I'm going to make a little bit more complex now, right? So first of all, we are going to assume two doors. So the two doors are, we have front door and then we have back door. So here we have front door and the back door. So this time we are going to assume like there are two door sensors, right? There are two door sensors. Likewise, that the two doors are represented as front door and back door. Likewise, there are two windows. We are going to say, okay, Windows 1 and Windows 2. So we have Windows 1 and Windows 2. And we are going to set the alarm signal, right? So I want you to design a circuit to alarm signal when any door or any window is open. So in this particular case, we have front door, back door, window 1, window 2, and we have alarm signal. Right? So any of the doors are open, 1, we want to output is 1, which means we can have a single one like this. Nothing wrong here, right? You can just simply have a single, OR gate. We will have OR gate. Right? It will be OR gate, one of these. Right. Now this is similar. You can, let's say we have only 2 input gates. So most common ones we have already seen, right? 2 inputs. Right. How do you make it 2 inputs? We can see, we can have 2 inputs. Like, for example, you can have this part separately, this part separately, and then you can add these 2 parts. So which means we can have OR gate in between here. So we will have OR gate, and here another OR gate. So we will connect here, we will connect here, this one connects here, and this one connects here. So it means we created these 2. Now we need to add these 2 again. So that means we need another OR gate. So this is if we are using 2 input gates. So simply we can put like this. So this is a simplest circuit possible for this one. Any of the input is 1, that means any door or any window is open, then the alarm will warn, right? Switch on the alarm system. So here is the equation. We know the alarm signal works when all the inputs are so added together. So in this case, use of O. Right, here is the skeleton, meaning like we have front door, back door, window 1, window 2. Now, for example, if everything 0 means all these doors and windows are closed. Okay, so likewise try. So when you have this, so that means when everything is 0, the output is 0. And all the other case, we know that at least one of them is set to 1, which means when you perform operation, the output will be 1. So everything will be 1 except the first one. Right. So that's correct answer. So in this particular case, we are going to uh, switch on the street lights based on the following conditions. We have 3 things here. We have a manual switch, irrespective of whether dark or light, evening or morning, whenever you switch on, that means when you close switch, the street lamp should on, right? Or else the other one is if the environment is dark and the time is between 6 p.m. to 6 a.m. So that means night. So the night time you are going to switch on. So that's the condition given to us. So now let's put up the status. Right. So when there's a light, because it's a light sensor, so when there's a light, it will set to 1. So when it is dark, So you can see when it is dark, we have to set it to 0. So this is 0. The time again, the time is between 6 p.m. to 6 a.m. So that's a night. So we want to set it to 1. And if it is from morning 6 a.m. to 6 p.m., we want to make it a 0. Then we have the manual switch. You can close the switch, switch on, right, or switch off, right? So these are the status, right? So this, once you identify the sensor, the inputs and outputs, so we know that it's manual switch, timer, light sensor, and the street lamp. So I didn't put the street lamp, but here if you put a street lamp, so on and off, on is 1, off is 0. Right. So what are the conditions here? Is it both of them should happen or one of them happen? We have to switch on. So that means in between these two, right? It could be anything. So we can simply use OR gate, isn't it? We can simply use OR gate. Why OR gate? Because we know, right? In OR gate, right? If any one of these, so we have two states, we have to connect these two statements using O. One of them is satisfied, then we'll get it. Right. So in this case, first of all, you have to make the states. So we have a light sensor, dark light sensor. So when there's a light, we can set it to 1. Then when it is dark, you know that it will be 0. Then the timer, in the timer, we are going to discuss 2 time periods, 6 p.m. to 6 a.m. So that is usually the darker time, right? Night time. So we can make it 1. Right? And morning, we can make it to 0. So these are the states. Manual switch, close means when you switch on, output is 1, then open is 0. Right, now we know from here we have 3 inputs: switch, timer, light sensor, and street lamp. Right, now occasions when lights are on, manual switch is closed. Irrespective of what this should be switch on the lights. Or else we have combination. In combination, right, so you are going to combine the output of these two. So let's see. The first one is, we know we have to combine this using OR gate, either manual switch or these two items, time and light sensor. So we know manual switch is closed, means you can connect it. Okay. And then that will be the output. Now the second one is when the environment is dark and time is 1. Time is 1. So that means you have to AND both them together. So the time is 1. The light sensor, the environment should be dark, meaning light sensor should be 0. So if that is the case, you can have an AND connected to the OR gate. So timer we can directly connect, no problem. But light sensor, we know if it is dark, it will be 0. If it is light, it will be 1. So which means, right, it's opposite. So we want to take this out, that is 1, 1. So this should be 1. So we have 0 in one side, and the other side we have to have 1. So how do you make 0 to 1? Then we can have, yes, NOT gate. Right. We can have not gate. So not gate will connect the two. So whenever the light sense is 0, that means whenever it's dark, right, it will input 1 to AND operation. And then you check the time. If the time is also evening, then that will be also 1. So you have 1 and 1, the output will be 1. Okay, so let's take down this one.